Hello YouTube. Ladies and gentlemen, today we are solving LeetCode question 621, Task Scheduler. You are given an array of CPU tasks, each represented by letters A to Z, and a cooling time, N. Each cycle or interval allows the completion of one task. Tasks can be completed in any order, but there's a constraint. Identical tasks must be separated by at least n intervals due to cooling time. Return the minimum number of intervals required to complete all tasks. So the solution that I have for y'all today is a greedy solution. And it's done by first counting all the frequencies of the task. So for example, in example 1, A is 3, B is 3. So after we count all the frequencies of the task, we want to find which task appears the most. So the max frequency is just going to be the max of, okay, first we're counting all the frequencies of the task and we'll put it into a hash map. And then we want to find the max of the hash map values, or the max frequency, or which task appears the most and how many times does that task appear. So in example 1, the max frequency would be 3. And we also want to see the max task, or how many tasks have the max frequencies. So it's where I'll let the train pass real quick. So the reason why we need these variables is because the answer to this problem is just finding how many idle spots there is. That's simply it. We have to find how many idle spots. So for example, you see these idle spots in the question? The answer is basically the count of idle spots plus the length of the task. You see how output is 10? They got this answer by counting this. So there's 6 elements here, and there's 1, 2, 3, 4 idle tasks. 6 plus 4 is 10. That's how they got this answer. Same here. There's no idle task, and the count is 6. 6 plus 0, 6. So the essence of this problem is finding how many idle tasks there are. So in max frequency and max task, we need these to find the idle task. And we could do this by doing this. So let's say we have A and B, right? That means we have to put it up like this. So the max task, okay, A and B. So it would be something like this. If the N is 2, it would be like this. Okay, there's another train, but this is a bad example, but you'll get it as I explain it. So we find the max frequency, we find the max task. We want to calculate all the slots in between the max frequency and in between the tasks by using these two elements. So the slots is max frequency. So max frequency is 3. It would be -1. Because, so slots is going to be max frequency -1. Because if you have A, and A, there's going to be 2 slots that goes in between these A's. So slots is going to be 2. But then there's an edge case. If B also have 3 frequencies like A, then we have to account for it. So slots is the question marks in between times n, which is how much we have to wait. And if there are multiple tasks with the max frequency, then it would be minus like this, which could just be simplified to n plus task or n minus max task plus 1. So we calculated the slots, and now we got to start filling the slots with our leftover tasks. So our leftover tasks is going to be the length of tasks minus max task times max frequency. So we already assigned the max task. So if there's one max task, which is A, we multiply by max frequency, which is 3. So we have 3 A's. So in example 1, if there's A, then there would be 2 max tasks and the frequency would be 3. So we would have 6 because we already assigned 6. So the leftover is the length of task minus the ones we already assigned. So that's the leftovers. And now we have the leftovers. We could start filling in the slots. So the amount of idle tasks is just the amount of slots we have after filling in the leftover tasks. And idle can never be negative. So idle would have to be a max of this and 0. We cannot have a negative idles. And then we could just return our answer by returning the length of task plus idles, like we said earlier. And the runtime of this is going to be O of n runtime, because we have to iterate through every element at least once to count all the frequencies. And then everything else is just constant time mathematics. Constant time mathematics for everything else, and it's just O of n for counting. And then the space is O of 1 because we don't use any extra space. So O of n time O of 1 space. And then we could just get right into the coding. So count all the frequencies. So our hash map is going to be a counter of the task. Max frequency is just going to be the max of hash map values. Max task is going to be hash map values. We're going to grab the values. We're going to turn it into a list. And then we're going to count how many times max frequency appears. And then our slots will just be max frequency minus 1. I have to put this in parentheses times n minus max task plus 1. And then leftovers is just length of task minus max task times max. See, within our idles will be max of 0, slots minus leftovers, and then we can return idles plus length of task. And that is the code in 6-7 lines. Oops, a little typo. 7 lines. Submit. There we go. Ladies and gentlemen, thank you for watching. Thank you for tuning in. We will see you in the next coding session. Goodbye. Peace out.